Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
Welcome back team, and we'll continue the container basics. Okay, so as a quick recap, or the points that we need to understand out of this whole story is, right, we would like to run our application inside a container rather running it in the direct on your virtual servers or like a EC2 instances when it comes to the AWS cloud, right? So running an application inside a container will give a many benefits, right, compared to the traditional way of running the application on the virtual server. As we have discussed about the benefits, right, or the advantages, right. So one is the cost optimization, less maintenance, easy to run your application, right? Easy to run multiple applications in the single host OS without having any dependency conflict. It's very easy to manage the configuration consistency across the different environments that we are going to have to ensure that the code is being promoted from a dev to the production, right? And yeah. So in order to run a application inside a container, and of course the performance gain is one biggest advantage, right? As the container is having a minimal OS, which is a light-weighted application or the light-weighted operating system, as the operating system which is inside a container is not having the complete OS, is not containing a kernel component, right? Hence, this is a minimal OS, right? So just to repeat again, when I say a minimal OS, it has a operating system that is a, no, that is just enough to run the application, whichever the application that you wanted to run and serve the thing, right? Not any other extra components, right? So that way the application will be lightweighted and it's very easy, quick. It's like a quick to bring it up and run the application inside a container, right? When the just to call out again, right? The biggest advantage that you get it here, right? Though technically all of your applications are running in the single system, correct, guys? If you look into the presentation that you see at this time, right? The container section, which is the third diagram, right? All the containers are actually running in the single system, correct? So in a way, can I use the statement that all of my applications are running in the single system? It's a single virtual server, right? Yes, but the applications are not sharing the operating system configuration, right? Each application has its own operating system. Each application has its own configuration. That way, the right the the applications are not sharing the OS configuration. That is what I'm trying to call out here again, right? So the advantage is you have the flexibility to configure the each application in your own way how you wanted it to be working without conflicting, without disrupting any other application running in the another container, though that is in the single system again, because the isolation is being taken care by the container engine, which is the Docker engine in our case. Good to have these points, guys. Yes, so now let's see how these things will be get implemented, right? Okay, so in order to run your application inside a container, right, as I said, the the images are already built and kept into the Docker Hub registry by these Docker people, and you go and get the image or the right image which is more relevant for your requirement, and then create a container using that image. Usually When the images are built and kept into the Docker Hub registry, the images are pre-packaged with the specific set of applications or with the specific set of the required packages in it. So you go and choose the one which is relevant for you. I mean to say, let's say if your requirement is to run a Apache HTTP web server application in a container, then you need to go to Docker Hub registry and search for the image which will be providing you the Apache web server application. If you look into the Docker Hub, right, there are 10,000 plus number of images that are available. Each image is actually serving a different components, right? You see the first one, the first image is actually serving you a Alpine minimal OS. So this one is just giving you the Alpine minimal OS alone. It is not giving you any pre-installed applications on it. Hope you are following me, right? That means when you are getting the images from the Docker Hub registry, the images can be just a plain text, just a plain operating system, or the images can include the minimal OS as well as the application like a Nginx application. You see here, this image is containing the BusyBox application, like how you guys know about Apache HTTP web server application. Same way, just Nginx, BusyBox are the different applications for different purposes, right? We don't need to worry about how all of these working at this time. I'm telling that there are different images that are available here. Each image is pre-packaged with some set of application stack or the packages in it. We need to go and get the one which is relevant for us, right? Not all the images will be containing some applications in it. Let's say if you take the other one here, Ubuntu, this image is carrying, or this image will have only the operating system in it. And you see here, Ubuntu is the Linux operating system based on free software, something. So let's say if you take this Ubuntu image, what is that you will be getting in the image, guys? Will you get Apache HTTPD? You won't get, right? You will get only the operating system from this image. You will not get any Apache HTTPD. You will not get any other applications as well. You will just get a minimal OS, right? And nothing else from this image. And let's say if you take the Python image here, you will get only the Python application, nothing else, right? And in the same way, let's say if I take Redis, right, you will get the Redis application. And of course, when there is application, the application alone cannot be serve you, right? Must be a minimal OS. So there will be a one minimal OS in it, and on top of that minimal OS, the Redis application is actually installed, configured, and packaged, and it is serving you, right? Like that, if you go and look into this, and now you see HTTPD. So that means this HTTPD image is carrying the minimal OS, which is mandatory, plus Apache HTTPD web server application, mandatory, in this case, plus any dependencies that would be needed to run the Apache HTTPD. Only that much of dependencies will be there in this, nothing else. Like that, go and choose the image which is more relevant for you, what is that you are looking for, and get the image. In our case, in this case, right, I wanted to have a Apache HTTPD web application should be up and running. So go and choose this one, right? Because this image is already pre-packaged, right? With all the minimal OS, HTTPD image, HTTPD software plus dependencies, everything, right? You should know how this image is configured. So we need to follow their documentation to understand this image is carrying which operating system, is carrying which version of Apache HTTPD web server application, and this Apache HTTPD is actually installed in which location, right? How to use that location. Everything has to be, follow in their documentation and use it, right? So now let me quickly go on to deploy this and show you how to access the web application. right? So in order to pull the image, right, you get into the Docker host. Uh, I will be keep on changing my terminologies, guys, because I can't jump on to the final terminology that we wanted to at one go, right? I will be slowly changing my terms. That way, it's very easy for you guys to catch it up. At this time, right, the EC2 instance that is currently running here, I'm going to call this instance as a host OS. Is that meaningful? Is that meaningful name for this? Right? Why I'm calling this as a host OS? Because my intention is not to run my application on this EC2 server directly, right? I'm using this EC2 instance as a host OS, and I will install the Docker engine on it. On top of the Docker engine, I'll start creating a containers. So for now, let me call this as a host OS or Docker host. Both are same, right? Let me, I just have logged into this instance already here. Let me install the Docker engine, right? Yum install docker -y. In your host OS, you only need a Docker engine, nothing else is needed here. Why? Your application is not using any configuration from your host OS. You just need a Docker host to be, sorry, you just need a Docker engine has to be installed, and the Docker engine has to be started. Verify that the Docker engine is actually running. Sorry. Yeah, it looks good. Let me clear the screen. Now, how exactly the Docker is working here? Because we know that the Docker engine responsibility is to manage the life cycle of a containers, in the sense Docker engine is responsible now to pull a image from the Docker Hub registry and create a container out of it and run the application inside a container and manage the whole life cycle of the container, in the sense stopping the container, starting the container, terminating the container. All these things will be handled by a Docker engine now. How exactly the Docker engine will do? And again, the Docker will not do by itself, right? You need to give the instructions to the Docker, correct? Hey Docker, could you please go and pull a image from Docker Hub? Hey Docker, could you please go and run a container, correct? So that is where now we should have some details about the Docker architecture, how exactly the Docker works. If you look into the Docker architecture information here, what I did, I just have taken one Docker host machine, which is the host OS, correct? I installed a Docker engine on that. Now my Docker daemon is actually running in my Docker host. When I say Docker daemon, which is a Docker D, that is a daemon that is currently running. When you run systemctl start docker, it is actually running the Docker D daemon. By default, the Docker D daemon is listening on port numbers called 2375, 2376. There are two port numbers that it is relying on. You all know, right? If you are, when you are installing a service and when you are starting the service, usually the service will be listening on a specific port, and the clients, whoever want to connect, the client will be connecting to that particular port number and will start utilizing the services. That's a very general concept that we see in the Linux systems, right? Here the Docker is actually listening on these two port numbers. So far so good. When you are expecting a application to be running on your container model, you go to the Docker Hub registry, then you search for the image that you wanted to based on the requirement that you have, as I said some time back. Here I'm just listing out some of the images. Don't worry, if you are not seeing HTTP image there, that's fine. Whichever the application that you wanted to run, then you go and look for that image and then take it up, right? Now I need to inform to my Docker daemon, right? Hey daemon, could you please go and pull the image? How will you be communicating with the Docker? So that is where you need a Docker client. The Docker client is the CLI application. Docker client is the CLI software that you need to install. The Docker client is now connecting to the Docker daemon. It's a casual, or it's very general concept, right? That we already familiar that the clients will be connecting to the servers. The server side, the services will be running on a specific port number. The client has to connect it to that port number in order to interact. This is a very general concept, right? So here from the Docker client, you need to run the commands. That command will be connecting to the Docker host on a port number 2375 or 2376. These are the default port numbers that are configured whenever you start a Docker daemon, until unless you go and change something in the configuration. Whenever you run a command called docker pull, it will connect it to the Docker daemon. Now is the Docker daemon responsibility to connect to the Docker Hub registry and pull the image, whichever the image that you have been requested for. The image that is downloaded from the Docker Hub registry, that image will be get stored in the Docker host itself. In the Docker host machine, the images will be get stored, whatever got downloaded based on your Docker pull command instruction. Once the images are downloaded, kept locally in the Docker host machine, then using that image, we need to create a container, right? So then we need to run the command called docker run. You see the command here. When you run docker run, the command will again go and talk to the Docker daemon. The Docker daemon will be using the image that is currently available in the Docker host machine, which is already got pulled. And from that image, it is going to create a container. From one image, you can create any number of containers that you like it, because the image is acting as a template. The image is containing the required minimal OS and the application and dependency, all the required stuff. It will just take that information and it will try to extract the information, and that extracted information will be running in a isolated layer, which is called as a container in this case. Right now, usually when you create a container by using a specific image, the image cannot be deleted when your application is running in a container. Good. Now, a question for you at this time, just to improve the thought process. Can I run multiple applications in one single container? Right? So by this time, you got to know that when you look into the Docker Hub registry, each image is specialized for one specific application, right? That means that image is already pre-packaged, pre-installed with the specific application that you are looking for. So in general, yes, a container will be running only one application. Even the images that you are built in, right? The images are built for a specific application, and it's not recommended to run multiple applications in one single container, right? So again, as of today, you all know only one application, which is HTTPD web server. But think of like there are n number of different applications in the world, right? So right, the containers are designed to run only one single application, not for a multiple applications. Any reason, guys? Let's say if I run multiple applications in one single container, that becomes the way how you are running the applications on your direct EC2 instances, correct? The reason why I came out from the EC2 model and running the applications inside a container is I wanted to have my application to be independent, isolated, right? Able to manage its own dependencies without having any conflict with any other applications. That is the reason, right? If you are again trying to put multiple applications in one single container, then all these applications will get into the conflict. You can't manage the versions and there are multiple issues will come. So always we need to have only one application running in one container. Being said that, in general, whenever you run a container from the image or at the time the images are created, right? In the image itself, the configuration set to that, hey, if this image is used to create a container, then because this image is designed for a specific application, the moment when the container is created or the moment when the container is running, this is the application that has to be set to started. In general, maybe simply put, the application is configured as auto start during the container runtime. Is it the right statement? That means whenever you run a container, the application will be running automatically for you. You don't need to run the application manually. That's what it is. Let's say if you are using Apache image to create a container, to run the container, you don't need to go and run a command called systemctl start HTTPD. No, the sysctl start HTTP command will be get executed automatically to bring up the application the moment when the container is running. The only reason is that container is configured for a specific single application only. So that application is set to start automatically and that will get started. We don't need to go and manually start any application inside a container. Makes sense, right? This is exactly like how you guys will be running systemctl enable HTTPD command. You all know what is enable command, right? That is like whenever the system gets restarted, the application will be started automatically, right? Yes, the similar setup will be done in the at the time of creating the images as well. So when the containers are started, automatically the application will be get started. Why like that? The only reason why I'm running the container is to run the application, right? My requirement is I want to run a application inside a container. Now tell me guys, for any reason, if my application is not running inside a container, do you think any value in running the container? No. In the sense, you'll get to know this in implementation. In the sense, for any reason, if the application is not running inside a container, the container itself will be get terminated. Sorry, the container itself will be get stopped. That means if the container has to be up and running continuously always, we need to ensure that the application inside a container is also running and healthy. For any reason, if the application is not running, your container will not run. Just to repeat, the point that we need to make a note here is the containers will not be in a running state if the application is stopped inside it. The container will be in a running state as long as the application is in the running state. That's how it works. That is the reason you don't need to start the application, you don't need to stop the application, right? You now onwards you run the container, automatically the application will be running. You stop the container, automatically the application will be stopped. That means we are not directly working with the application layer now. You work at a container layer that automatically takes care of running and stopping the application inside a container. You just worry about your container, not about a application. Because if the container is in, I mean to say, when you run the container, the application is controlled automatically, and we will definitely see how that is happening here. Most of the things probably we can't show in a demonstration at the moment when I'm giving you the point. It takes some time to get into all these different scenarios to be implemented. That's the reason we are spending some theoretical understanding. We need to have some logical thought process as well to get the things. So now a question for you. Since now we know that if a container has to be in a running state, the application must be running inside it. Now the question for you, right? If I take a Linux image from my Docker Hub registry, maybe a Ubuntu, right? I will take a Ubuntu image, or I will take a Amazon Linux image from my Docker Hub registry, right? That Amazon Linux image will contain only the minimal OS, right? It is not containing any application or any other things, correct? If I take a Amazon Linux image and if I run a container, do you think the container will be running? No, right? When you create a container and run the container using Amazon Linux as a image that you pull from the Docker Hub, your container will not run. What could be the reason? Because the Amazon Linux image that you pull from Docker Hub registry that has just a minimal OS, it does not have a application in it. It does not have a HTTP in it, right? So when you run a container, is there any application to start? Sometime back I was saying that, right, the container will be in a running state only if the application is running inside it, right? Considering that point, if I take a Amazon Linux OS and if I create a container out of it, that container will never be running. Why? There is no application in it. There is no application to start. Without application, there is no container. It will be in a running state, right? Yes. If the application is running state, then the container will be in a running state. If application is stopped, your container will be get stopped. That means you cannot keep your container running state just by keeping a minimal OS. Is that clear? Right? Your container will never be in a running state just by keeping a minimal OS in it. No, it must be having any application started listening on a specific port number, right? Then only your container will be in running state, or else no. We'll look into that practicality as well. Now, moving forward, we are discussing about the container characteristics, right? How the container will be, behaving. Now, moving forward, yes, we can create multiple containers like that. The Docker client CLI can be installed separately on the different system and can connect it to the Docker host, or the Docker client CLI can be installed on the Docker host machine itself. That means the Docker client CLI and the Docker daemon, which is the Docker server, both can be in the single server as well possible. Usually when you install a Docker by using install docker command, that install both. That command will be installing the Docker daemon, which is the server component, plus it will install the Docker client as well, which is the Docker command line. now. You all know, right? When the client want to connect with the server, always the communication will go to the port number, right? Now, my client and the server, when I say server, the daemon, the client and the daemon both are running in the single system itself. Now, tell me, guys, do you think my client would need to use the port number to connect? We need a lot of networking thought process here, right? No, right? If the client is installed somewhere else, then it has to connect via the network and it has to reach to the specific port number. If the client CLI is installed within the same server, it need not to go via the networking route and it need not to use the port number. The client which is in the same machine, right? The client which is in the same machine can connect to the Docker daemon using the local socket concept. Local socket in the sense it can have a communication to the Docker daemon without using any of the port numbers help possible. That is called as a local socket. The communication is not coming from outside, right? When the client is installed in the same machine, the communication is not happening outside of the world. The client and the server both are in the same system. If the client is somewhere else, then the communication will come over the network. It will come over the security groups. It has to allow the port number, then reach the server. All these will happen. When the client and the daemon are in the same system, do I need to really worry about the security group? Do I need to care about the port numbers at all? No. Usually, only the daemons will be running and listening on a specific port number. The client will just use that port number to connect with. There are multiple examples we know about these things, right? SHS, HTTPD, right? Many other. Anyway, so in this context, right, we don't need to use the port numbers. We don't need to use the Docker CLI outside of my client, my Docker host also. What I do, I'll use my Docker client CLI within the same box itself. Then I will not use any port number. It can connect to the Docker daemon using the local socket. So I don't need to do any further configuration on it. Straight away it can work for you. So that is what is here. So I have a Docker host with me and I just have installed a Docker daemon. Now it is actually installing the Docker CLI as well. So I can see that the Docker CLI is currently working. Any command that you are running now, this is called as a Docker client. It will automatically connect it to the Docker daemon, which is currently running on the same system itself using the local socket concept. Well, I can see the Docker version is almost 24.0.5. That is fine. The docker hyphen version, and you can run the docker info command to get more details about the Docker, and it is saying that you see this. The Docker client software is running with the so and so version, that what you can see here. The Docker server is running with the so and so version. You can see that as well here. In my case, client server running in the same system. That is what it is. Right? Now it is showing the server component, all these things. Good. It's a general practice, right? Whenever you install any service, every service will be get installed in a specific home directory, right? /etc/docker is the location where the Docker configuration is being deployed, right? And etc docker location will have the details or the configuration of how the Docker daemon is working, how it is managing the containers, all the configuration. As of now, the etc Docker is showing empty. So let me show you one more. Right. So there is one more I would say home directory called var lib docker. The var lib docker is the another uh, configuration directory where the Docker is going to keep all the information. So you are not going to do anything with these files directly, right? You are not going to modify any data in this, right? I'm just giving you some information that the Docker is going to use these files and the folder structure to maintain some containers related data. We are not touching this directly, guys. You always work with the Docker using the Docker command only. That Docker command know how to use the data in this location, how to modify the data, manage the things, all these things behind the screen. But just to get some idea, the most of the Docker containers related information will be kept in var lib docker folder location. Anyway, now let me clear the screen. Our goal is to run my Apache HTTP web server application inside a container and access the website from the browser, right? So what I do is, let me see, is there any images that are currently there in my Docker host? As of now, none, right? So Docker pull HTTPD is the command to pull a image. Whenever you run Docker pull and specify the image name, by default, it will be pulling the image from Docker Hub registry only. You are not telling, right? The image has to be pulled from where, correct? I did not tell anything. I just given a name. By default, it will be pulling the image from Docker Hub registry only. If you want to specify, no, I want to specify that the image has to be pulled in from where, right? If you want to specify, you can specify the website address as well, from where you are expecting the image has to be get downloaded, right? As of today, I'm showing you how to pull a image from the Docker Hub registry, right? But the image is the base, right? The image is the important in the Docker world, because if you have the image, you know how to run a container, all these things, right? So right, so the Docker images or the container images can be stored in different registries. The images can be stored in the Amazon provided ECR registry, can be a Docker Hub registry, can be Google registry, and the JFrog. You can see many other as well. Possible. It can be anywhere on these different registries. But I'll definitely show how we can use the Amazon ECR since we are more leaning towards the AWS concept. But for now, let me get started with the Docker Hub. Because the images can be downloaded from any registry that you see in the list, right? Usually you need to specify the image has to be get downloaded from where. If you don't specify, it will choose Docker Hub as a default. If you want to specify the registry name from where you are expecting it to be downloaded, then it's your registry name slash. This is how it should be. If you are expecting the image to be downloaded from Docker Hub, then your website name will be docker.io, guys. If you are accessing the Docker Hub registry from the browser, then it will be hub.docker.com. Okay. If you're accessing from browser, then it will be hub.docker.com. But if you are referring this in a CLI mode, then it will be docker.io. So docker.io slash, then specify the image that you wanted to download and just hit enter. If you don't specify docker.io, not a problem. By default, it will be considering the same, right? Now you see that the image is downloaded. I can see that in docker images command, every image that is downloaded will have a image name and the image tag. The image tag is referring the image version. We'll talk more about this in down the line. For now, the tag is latest, which will be having the image ID, the size of the image, and some like when the image is recently published into Docker Hub registries. Good. Once you have the image with you, right, then you need to run the command called docker run in order to run it as a container. Docker run -- name, specify the name of the container -d so that your container will be running as a background process, or else if you don't give -d, your container will be running as a foreground. You all know, right? It's not a good idea to run it as a foreground because you can't run any more commands. If my session gets terminated, your container also will be get killed, right? So I want to run my container as a background in a detached mode. Then specify the image name that you wanted to. Now you hit enter. It will create a container ID. The container ID is very big, lengthy numerical number. I think it may be having almost 64 characters in it, right? Now, if you do docker ps, this command will tell you the list of running containers, right? Every container will have a container ID. The container is created from which image, the container is created, and the other information here. And this container is listening on which port number. I'm done. As I said, when you run the container, automatically the application is running inside a container. You don't need to go and start the application manually. Which application is running in this case, guys? Because my image is HTTPD, which is pre-packaged, pre-installed with Apache HTTPD application. So my Apache web server is now started automatically and listening on port number 80. It is started serving the website already. Right? So looks good. Now I'm keep saying that now the HTTPD web server is running on this container. It is running on port number 80. So how do I access this application, right? Let me take that scenario now. So this is my Docker host machine, correct? This is my Docker host machine. In this Docker host, what I did actually, right? In this Docker host, I have, right? I went to the Docker Hub. In the Docker Hub, I have selected HTTPD image. You can select any image that you like it based on which application that you are interested on, right? So I have taken HTTPD image. I pulled this image to my Docker Hub registry, sorry, to my Docker host. Now the HTTPD images came here. Using this HTTPD image, I just have created a container. Now this is my container. Now help me guys. I maybe keep on repeating just to avoid some confusions because at one go we can't catch all the things, right? When you download the image from the Docker Hub registry, help me, what and all things will be downloaded as part of this image? What is that the image is carrying in this case? The image is carrying HTTPD package, which is already kept into the image format. This image is carrying some dependencies that would be required to run my HTTPD application. This is carrying the minimal operating system which is needed to run my Apache HTTP web application. And of course, the HTTPD web server is set to auto start, right? The image is already configured to start the application automatically whenever we run a container. That configuration is already done, right? So maybe I'll say application configuration in high level terminology, right? In a bracket, I'll keep this some configuration, right? So all these things are now downloaded as part of this image. When you create a container out of this image, then obviously, right, now inside this container, if I ask you one more time, what and all things will be there inside a container? Inside a container, now my HTTPD application is there, right? Inside a container, I have the HTTPD image, I have some dependency packages, I have my minimal OS, and my application is started, correct? App is already started, right? Whatever the commands that it has to run to start the application, that is already configured and it is started. And the application is actually started listening on port number 80 number. My application is currently running inside a container and it is listening on port number 80, right? The Docker host, which is your EC2 server, right? Your EC2 server has a IP address, correct? Some IP. In my case, if I go to the actual values, let's say this is the IP. This is my EC2 server IP. Now, if anyone want to access a website, let's say I have the client here who wanted to access the website. This guy is running http:// right? Then specify the EC2 IP address, right? Then hit enter. That means the client is actually sending the request, the HTTP web request to the EC2 server to get a or to access my website, but it won't work. Why? The client is sending the request to the port number 80 of your EC2. Do you think the port number 80 is currently listening by your EC2 server? No, right? Because my application is not running on the EC2. My EC2 is not listening on port number 80 and it will not work. My application is inside a container. The container is always be accessible as a private purpose, in the sense the application running inside a container will never be accessed by the users from outside of the servers directly. Always the connection should come via the EC2 server only. The connection cannot go to the container directly like this, no. Right? All what you need to do is, in the Docker host, because the Docker host is already running at a EC2 server, right? To Docker host, you need to tell that, hey Docker host, whenever you see there is a request came to the port number 80 at your EC2 server level or at a Docker host level, can you please take care of taking this request and forward the request to the container? This is called as a port forwarding concept. So you need to do the port forwarding concept, right? You need to do the port forward in order to access the container application from outside of your Docker host or outside of your host OS. If you are not doing this port forward, you cannot access the application. Even today, my application is already running in a container. My website is already running, but I can't access. Why? The port forward is not configured yet. You cannot configure the port forwarding once the container is in the running state. In this case, my container is already running state, right? This container is actually running since last 19 seconds. If I run the command one more time, since last 8 minutes it is running. Now if I want to go and tell that, hey, please do the port forwarding, no, you can't. The port forwarding should be done before you actually run the container. That means some container configurations cannot be changed dynamically, right? At least the networking configuration cannot be changed. We need to do this at the time of starting the container only. Being said that, now I can't access this application. Let me destroy this container. Let me create a container again. The next time I'll use the port forwarding concept. Make sense? So what I do is currently my container is running, but I can't use this application. So docker stop is the command to stop the container. When you stop the container, automatically the application running inside a container will be get stopped. We know that. When you stop the container, the containers will not be showing in the docker ps command because the docker ps will show you only running containers. If your container currently stopped, then you need to use -a flag to see them. Now you see that the container is exited some 24 seconds ago. Once you stop the container, then you can start. We can remove this. Docker rm is the command to remove the container. Now your container is gone. Nothing is there. Cleaned up. Now let me run the container one more time. At the time of me running the container, you need to specify -p flag for doing the port forwarding, saying that, hey, the port number 80 at your Docker host machine level to be get forwarded to the port number 80 of your container. And now you hit enter. If you do docker ps now, you see that the container is actually having the port mapping or the port forwarding. So now any request that comes to the 80 at your host machine will be forwarded to this particular container. And the response will be given and users can access the application. Now tell me guys, I'm running the netstart command on my host OS. Can I see a port number 80 is listening? Should be, right? Of course, my application is not running on the host machine, but at least my port number 80 should be in a listen state now because I made a port forwarding. If you see the list here, the port number 80 is actually listening. Who is listening this port number, guys? Is it Apache HTTP web server? No. If you see here, this port number 80 is actually listening by a service called a Docker proxy. Docker proxy is the service which is one of the Docker daemon. The Docker proxy service is responsible to listen at a host machine level and forward it to the container port number. That job is done by the Docker proxy here. That's where you can see Docker proxy is listening on port number 80 in order to forward it to the backend actual container application. So far so good. So as of now, this particular port number 80 is actually mapped to my container, right? Looks good. If at all you have one more container for any other application, something like this, right? If you wanted to access that application, yes, you need to do the port forwarding, and you cannot use the port number 80 again. Go with any other port number, right? When you're running the another container, just choose another port number. 80 is for one container, 81 for another container, 82 for another container. You take a call how you want it to. But the same port number cannot be, port forwarded it into the multiple. That doesn't work basically. Good. Now let me try to access my application. Obviously, right? Now I'm sending the request to my EC2 server, right? So the EC2 server should be able to allow the port number. So in the security group, I will allow the port number 80. Right? Now let me go back to my EC2 to get the IP address. I'll go to browser, http:// let me specify my EC2 IP over there and hit enter. Now you see that you got your website here. From where I'm getting this website? Is that the website that I'm looking for, guys? Not really, right? This is the default sample website that is coming maybe as part of your image. Maybe when you get some image, the image is carrying some default index.html, then that is giving you one simple page like this. But that is not what I'm looking for, right? I need my own website to be served here, correct? I'll show you that just for getting the confident. So this is the container which is actually serving the website at this time. If I go inside a container by running docker exec execute a commands as an interactive mode on this container, right? Execute the bash shell so that I can get into the shell of this container, right? In USR local Apache 2 folder in the htdocs folder, you can see a file called index.html. If I look into that file, you see that it is actually a HTML sample code showing it works. This is the file that is serving, and you see that it works is coming as a header or heading in your output. I'm just confirming you that this is the code that is there, and that's the reason you are getting the same website in your case. Why I went to USR local Apache 2 htdocs? This is running with Alpine Linux operating system, and as per the Alpine Linux, this is the location. How do I know? As usual, I need to get into their image and follow the image documentation, which explains that the location where the code has to be. Good. Currently, I am inside a container, guys. Now, any commands that you are running, all these commands will be running inside a container. Now, can I go and change some code in this file so that I can start seeing the changes in my website, right? So what I do is, let me try to do some changes. Okay. VA is not found. Interesting. So currently I'm inside a container, right? Can I see a command? Sorry, can I see a port number 80 is running? Ideally, yes. The netstart command should able to show you that the port number 80 is in running state, right? Yes or no? Because currently I'm inside a container. Yes, inside a container, my Apache HTTP web server is running and it should be listening on port number 80. Yes, you should be able to see. But the problem is the port number will be running, that is sure. There is no doubt in it. But the problem is the command is not available to show the information or to see the information. Why all these commands are not working? Because this is a minimal voice. That's where we need to understand what is it mean by the minimal voice. Minimal voice in the sense this is the operating system which has very limited information, limited configuration needed to run the application. To run the Apache HTTP web server, whatever is needed, only that much of stuff will be there. Anything extra will not be there by default. That is what it is, a lightweighted application. To run the HTTP web application, I don't need a VI editor. I don't need a nested command. So it is not providing all of these. It's very difficult, right, to do some analysis, changes, all these things inside a container without having all these commands, because we are very much familiarized to use these commands to do some testing, all these things, right? But yeah, your container will not provide all these additional commands since it is running with the minimal OS. Now, anyway, so my goal is I wanted to change this index.html code because I don't want this default website. I want to have my own website, right? How do I do that? Let me do exit for now. Back to host OS. Let me come back here. As of now, okay, as of now, in this scenario, the image that you pulled, is that image containing your code? Basically, to serve a website to your user, you have developed your own website, you have your own code. That is the code that you need to keep in your server and start serving the website, right? Now the question for you, do you think the code that you wanted to host, is it coming as part of your image? No, right? So the images are built as a generic way by the Docker people, but it is not containing your specific custom configuration based on your company project application, right? All what I need to do now is, right, mostly the code, right? Mostly the code. You take your custom code, whatever it is, right? You take the code and this code now I need to copy inside a container. You take the code, whichever the code that you wanted to run as a website, then you copy the code to inside a container. Then it should work. How to do that? Right? So I just went to my default location, nothing else. All what you need to do is create a index.html file in your host machine level, or it could be anywhere where you are running the commands. Let's say this is my own website. This is my custom code. Don't worry, as of now, I'm just putting one line of code. We need to understand the concept, right? So now let's say this is my customized website code. This is the code that I wanted to run in my container, right? So Docker PS. All what we can do is Docker CP. Docker CP is the command to copy the file from your host machine to container. So the source is your host machine and I have already created a file. That file I am copying it into a container. Specify the container ID colon, specify the location to which location you wanted to copy the file. What will be the location, guys? This is the location, right? Copy the file into that location. File is successfully copied into the location. You want to know that? Docker exec, right? And specify the container ID. right? And let me see, I want to know the files, maybe a cat command. I want to see the content of this file. How many of you getting confusing now? You see here, I'm running Docker. Hey, I want to execute a command in this container. This is my command that I wanted to execute. So this command will now be get executed inside a container and it is giving you the output. So simple. Why I have given a -it as an interactive mode is mean that sometimes if you wanted to run multiple commands, I don't want to run like this, right? Every time. That time you run the command called bash that will give you the shell. Then you start running the commands. So it's your flexibility how you want it to. That is what is called as a interactive mode to run a bash shell or to get a bash shell. Clear? Now, yes, I got my code. I can see the changes there. Now let me go back here and try to access my application. Now I see that my website is running with my own code. If you stop the container, let's say docker stop, docker ps-a exited. Now you try to access the application, it won't work. I'm just trying to prove that it is coming from this container. Again, you start the container, docker start, docker ps. I started the container. Now you see that application is working. So when you start the container, application is started automatically. When you stop the container, application stopped automatically. That's what I'm trying to prove one more time. We will not be using any commands like systemctl start httpd. No. So far, so good. Now the code is ready, right? Let's say the developer says that, hey, my code is ready, correct? Let's say sometime back I have shown you the code, right? This is the code. The developer says that, hey, the code is ready. Can you keep this code in the dev, then to the QA, then to the perf, towards the production? That's how the flow works, right? Let's say currently I have the container right here. This container is currently running my application. It's all good. I'm able to access my application as well here. Everything is fine. Now a question for you. What is the case if my entire EC2 server gets terminated? Correct. If my EC2 server gets terminated, obviously the container that is running inside a EC2 will be gone. Correct. I mean to say, once my application is running as expected, yes, I'm happy that my website is running here from the container. Now the time to think of, is it highly available? Is it scalable? Is it highly secured? Is it load balanced? Am I following all these best practices for my application or not? That is what I'm trying to look at now. You cannot change the port mapping details once it is in running state. You have to do that only at the time of, right, the when at the time of you're running the container. After the container is in running state, you can't do any changes for that. Now, so currently this is not highly scalable. It is not a highly load balanced, right? It is not auto scalable as well. Can I do a AWS auto scaling, guys, now to scale my application? Let's say more people are accessing my website. Okay, let's say this container application is not capable to handle the load for whatever the reason. Can we scale it up? Of course we can do that, but at the moment no, right? At the moment my container is not following all these best practices. Can you have, we'll take a pause and we'll try to think of, do you think the AWS load balancer or the AWS auto scaling group, because those are the two primary components that we have used to auto scale, to load balance, to highly available, all these best practices, majority best practices, we followed it using the auto scaling group and load balancer, right? Can we apply the same load balancer auto scaling concepts now to get my application highly available when it is running in a container mode? Not really, right? Why? The AWS provided auto scaling group and the load balancers are applicable only if your applications running at a EC2 servers directly, correct? That means the AWS provided load balancer and the auto scaling groups are capable to give you the all the best practices at a EC2 level or at a server level. But here I need a application to be all these best practices at a container level, because my application is not in a EC2, it is inside a container. That means for some reason, let's say your container got crashed, right? For some reason your container is now stopped unexpectedly, your application is down. Where is the high availability? So all these things cannot be handled using AWS auto scaling and load balancer just like that. We need to have some more extra concepts that are provided by Kubernetes. We'll definitely get into there. Okay, so now, so in order to get into all these other best practices that we are trying to write, what I do is, let me start it again, right? So in order to get all these best practices, right, the container that is currently running along with my customized code, from this container, because the container is already having my custom code, right? From this running container, I'm going to create a image out of it, possible. From the running container, now I'm going to create a image that is my customized container image, and that image I'm going to publish back to my Docker Hub registry. So I'll create an image, I'll keep that image in my Docker Hub registry, guys. Now a question for you at this time, if I create an image from this running container, what will be there in this image? This is the custom image that I'm pushing. I can create an image, I can push the image into my Docker Hub registry. What will be there in this image, guys? Can I say this image is carrying the HTTPD packages? This image is carrying the dependency. This image is carrying the minimal OS. This image is carrying the app configurations. More importantly, now this image is carrying my code. This is the additional stuff that I'm doing, right? It has my code because I copied the code into a container, right? From this running container, when you create an image, that image will bring or will contain the code as well. Now you keep that image in the Docker Hub registry. This is your own customized image. Simply put in two-liner, what I did, I have taken a image from the Docker Hub registry. I copied my customized configuration in it, which is like a code. Then I take an image out of it and I'll keep this image in my Docker Hub registry. Once my custom image is available in the Docker Hub registry, now tell me guys how easy it is to create a container and run the application. Whenever I ask you, hey, could you please go and run the container? All what we can do is take this custom image and run the container. That's it, right? Do I need to copy the code again here? No, right? Because the image that I'm using here, this is the customized image that I prepared myself by adding my code also in it. So when you take this custom image to create a container whenever you want to, the container will start running your code directly, right? Without having any issues. You don't need to do any changes. Take the image, run the container, use the website. Don't copy any code and all. That is already done in this section. Being said that, the goal here is whenever the developer give you the code, right? Whenever the developer will give you the code, hey, this is the code that is ready, please take care of. All what you need to do is take the code, create a custom container images, and keep the images in the Docker Hub registry. Then use that image whenever you wanted to run the application, wherever you wanted to run the application. Make sense? Being said that, the whole process that I'm doing here, can I say this is the Docker build process? Right? I'm saying that this is the Docker build process or the container image build process. Why? I'm taking the code, I'm taking a plain default image, and I'm copying the code, create a custom image, putting it into the Docker Hub registry. I'm just preparing that process because I need a image. Once I have got the image, then I can run a container wherever I wanted to later part. I don't need to worry about any of this. So being said that, I'm doing some build process here to build my custom container images. Then this EC2 server, I'm calling it as a build server. The EC2 server that I'm currently working on, this EC2 server, I'm calling it as a build server. Why? This server I'm using to build my images, and I'll keep the images in my Docker Hub registry. Let me do that now. Docker commit is the command to create an image from the running container. Docker commit. Docker commit. I just executed this to get some syntax, guys. Okay. Docker commit, then the container ID, then your container name, sorry, image name. The image name will always be in this format, okay, in this format. The repository, to which repository you wanted to publish the image once it is created, then the image name and the image version. This is how the format will be. I'll show you the format now. Once my image is created, I want to publish this image to docker.io, correct? Once this image is created, I want to publish or I want to upload the image to this docker.io. Following me? In the docker.io, you should be having a account created, guys. Docker.io in the sense hub.docker.com, both are same. Docker.io is a CLI side and hub.docker.com is at a UI side, right? So once the image is ready, that image I wanted to upload to this Docker Hub registry, correct? So you specify the registry website to which registry you wanted to upload. Then in this registry, you might be having an account, right? You can create your own account, guys. It's a free of cost. Maybe I'll show you that. You can go to hub.docker.com website and you can go to the sign up option and create an account by yourself. Once you create account, then log into your account, right? Then your account will have a account name. Actually, in my case, my account name is DPT Hub. This is my account name. So in this Docker Hub registry, I wanted to upload a image to this particular account, right? So the account name has to be given in this. After this, you need to specify the image name. Let's say this is a DPT11 image. DPT11, let's say HDPD image. Any name would be fine. After the image name, you need to specify colon and specify the version. Let's say this is first time I'm preparing the image, right? Let's say this is 1.0 version, the first image. This is the naming convention of a image that you need to create, right? That you wanted to publish to your registries, guys. This naming convention will help the Docker to know that the image with the version 1.0 to be uploaded to docker.io to the account called DPT Hub. That's how this image name is helping the Docker Hub. Sorry, helping the Docker engine. If you want to publish this image to, let's say, AWS ECR, then in the docker.io place, you need to keep the ECR website name. In the DPT Hub place, you need to keep the ECR username and the image name and the version, something like that. But this naming standard is mandate. Without following all of these, you can create image, not a worry. You see that now I'm creating Docker commit. I want to create an image from the running container and my image name is HDPD new. I'm just giving some name. You will get it. You see the Docker images. Now you see that you have got a one more new image. So you can create an image with whatever the name that you like it, but this image is currently in your local, right? In your Docker host. If you want to upload the image to the registries, then only you need to follow the naming convention. Why you need to upload this to the registries? If your image in your local machine, you can't use it wherever you want to, right? Or whenever you want to. If you upload this image to the Docker Hub registry or any registry that you like it, then it's just matter of pulling this image wherever you want to and can run the application. Tomorrow, I'll use this image, pull into dev, run the application over there, pull into QA, run the application over there. That's how same image will now being promoted to all the different places. Now you see this image I can't upload because this is not following the naming convention, right? So if you have the image already, yes, it is possible to change that image naming standard by following the docker tag command, or else we need to give the naming standard at the time of running the commit command only, or else I can change it now also. Now you see that I just have created a DPT hub slash the image name and the version is like 1.0. You can't see the docker.io because that is a default, right? And it is automatically took care of that. Now we need to push this docker push specify the image name, colon, which version. 1.0 is the version because first time I'm creating 1.0. You can give any number that you like it, but usually 1.0 is good thing. Now it is actually uploading. Of course, it is saying that the access is denied because, right, the people cannot upload to this account directly, right? It need a access permission. So you do a Docker login first. DPT hub is my username and specify the password. Once you log into your account, then you try to push. The image is now being uploaded to your account. Yes. Once I created a image with the HTTPD -new, then I have like I created a one more image out of it with a different name. That is what I did a Docker tag. I think right in the Docker tag command, I actually created a one more name out of it because this image I can't use as it is to upload. I need to follow the naming convention, right? If you have followed the naming convention at the time of running the commit command itself, then we don't need to. But I'm showing all the different ways. Now if you come here and just refresh your account, now you can see a image which is containing your customized code as well. You see dpt11-httpd 1 minute ago. This image has everything to run your website, including the code that you wanted to. A question for you at this time. Now I have my image here, right? Using this image, I can run a container whenever I wanted to, correct? The question is, do you think do you think this build server is needed? At least for this particular project, I don't need a build server now, right? Why? I created this build server because I wanted to create my customized image. So in the build server, I have pulled one default HTTP image. I created a container. I copied my code, or I made some customization in it. Then I put my, no, I created my new image. I pushed it. Once this is done, I don't need a build server. Why? Take this image, run a container whenever you wanted to. Agree with me? So the EC2 server, right? The EC2 server that I'm currently working on, I'm calling this server as a build server now. I'm just changing my terminology. So this build server, I will be using only to build the Docker images. I'm not going to run the real websites from this machine, guys. No, right? This EC2 server, I'll just use it as a build server. I'll take the code, I'll take the Docker default images, I'll try to run some commands, build a new images out of it, and I'll push it to my Docker Hub registries. So that is what I'm trying to do in the build server, not for running actual websites for my business per se. No. If you want to run your application, right? Maybe in this build server, now tell me guys, do I need to run this container? Is there any reason for me to run the container now? No, right? Because my purpose is not to run the container, right? My purpose is not to run the application in this machine. No, I ran the container just because of I wanted to make my own customization. This is like, you create a EC2 server, you do some customization, you create a golden AMI out of it, then you destroy the EC2 server, you have got your golden AMI, use the golden AMI to create any more servers later part of it, correct? The similar thing that I'm doing here, nothing new. So I don't need a container now. Docker stop, Docker RM. We can do the cleanup as well if you want to. We can clean up the images as well by running, right? Docker RMI is the command to remove the images if you wanted to, whatever. Even I don't need the build server as well. I can go and delete the build server as well. So now, once the build is completed, that means the developer has given you the code. You have done the build part now, where you created an image out of it. Once the image is ready, now I will ask you, hey, can you please deploy this image into the dev environment? That means that is where I wanted to run my application as one of the environment. I'm not going to create a AMI out of this. I don't care about it, right? Why do I need to take the AMI of my build server? I don't have anything in my build server. All the application that I wanted to run, all the application is currently there in my Docker Hub registry, in my image, right? This is what is important for me. This is the image that has everything for me to run my application. Nothing there in the build server. Why do I need to care about it? But I just compared it. How you guys working at a EC2 level to take the gold AMI pod. This is how I'm creating a container image and use that image for running multiple containers wherever you wanted to. Yes, everything is already exported to Docker Hub, right? Nothing there in the build server. I can just go and terminate this build server. I don't need it. I'm doing all this just because you should understand that, right? Uh, uh, the customization is now into a image format. The image is in the Docker Hub registry. Now, if I ask you, hey, could you please go and run my application? I wanted to see how it works. Now that you need to do in the application server. So you will be having a one more EC2 server, which I'm going to call as a app server, right? This is my app server where I wanted to run my applications. This is my application server where I wanted to run the application. The build part is already completed. I have the image ready in my Docker Hub registry. I just need to start running the application now and from this app server. So let me logging into my application server now. The reason why I'm following all this, you should understand the process side of world as well, right? What is build part, what is application, right? As I see a question there in the chat window, yes, I can simply download an image into the same build server and I can show you. This is how you pull the image, you run the container. Then it will be a question now, right? Already there is a container running here. Why I'm terminating the container? Why I'm pulling the image again? Why I'm running it again there? Got me? That's the reason I'm introducing the process here. All this I did it in the build server. Now I wanted to run this application in the app server, right? So this is the application server where I wanted to run my application. As usual, since this is a brand new server, I need to install the Docker. Without a Docker, we can't do anything, right? Systemctl start Docker. Now the fun part begins, right? The developer has given the code for us, and what we did, I went to the build server, I created a custom container image, I uploaded this image to my Docker Hub registry. Now the developer says that, hey, can you please put the code into a dev server? I wanted to test how the code works. All what you need to do is Docker pull, right? Docker pull. This is the image. Sorry. Docker pull. You can just go to this public view. You can copy the command from here also, right? Docker pull. You need to specify the version as well, guys. You see the tags section here. 1.0 is the version that I mentioned, right? So you need to specify that version as well. I'm just pulling the image from there into my application server side. Now let me run the container, right? What I do is Docker run hyphen name. Let's say this is the website that I'm running for my dev environment purpose as a detached mode. Do a port mapping to 80 to 80 and the image name colon which version of the image that it has to use and run the container. Docker ps. Now what I did, guys, I deployed my application it into dev environment, correct? This container is currently running the application, right? This is, I'm referring it as a dev. Now I will inform to developer that, hey, application is running as a dev. Please access this website and see if your code works. How do they access it? Tell tell them that the dev is accessible on port number 80. Please use it and work it out. So obviously you need to allow the port number, guys. Port number 80, I'm allowing from anywhere. Okay. Detached mode in the sense background. Run it as a background, not as a foreground, so that it will be running in the background without any interruption. Right now, you give this URL to developer. The developer will be accessing this website. As of now, it is on port number 80. You see, is it working, guys? The code which is expected. This is the code that we got it from developer, and this is the code that I have customized it into my image, right? So now what I did, I just took the image from the Docker Hub registry. I ran a container, and it is working. You don't need to do anything now. You don't need to copy the code, all these things. It's already good. Now you inform to developer. The developer will go to this URL. They will verify this, website. They will verify whatever they wanted to from the developer standpoint. Once they good that, hey, the dev is good, the dev URL is good, website is working as expected, look like my code is good, they give the approval. Now what you do? Put it into QA environment. For that, what you do now? It's the image is same, right? It's the image is same. All what you need to do now is Now let me put it into a web hyphen QA. I'm just right.
But only the Docker Hub screen is coming, sir.
Yeah, gotcha. Thank you. Right. So let me show it back again. You see, right? So the website is working over there. The developers will use this URL, verify that yes, my website is working good. Please go to the QA environment. Now what you do is in your app server, I'm running the container one more time. I'm running the container one more time. This time you see the name, I'm just giving web hyphen QA. I'm running the second container, which is for QA purpose. Now I can't use the port number 80 because 80 is already used by a dev. Now let me use, let's say 81. Docker PS. One container is running on port number 80, that is for dev purpose. Another container running on 81, that is for QA purpose. Now you inform to QA team, hey, application is deployed, please go and verify it, right? Of course, now it is running on 81, so 81 port number should be right allowed in the security group. I'm going for custom TCP, guys, because if you go for HTTP here, that will be filling this port number automatically. In our case, I don't want to go with 80, right? 81. So it will be a custom. Then you fill up the number over there and save the rule. Now you inform to QA team. The QA team will be accessing the website on port number 81 in this case, and they will get the website. This is coming from my second container. They do whatever the testing that they wanted to on this QA portal, then they give the sign off. Then you proceed with the perf environment deployment. All what you need to do is again run a container. Now I'm deploying it into a perf environment. Maybe the port number should be changed. The image is same that what you are trying to look at there. Now you inform to performance team that hey, now the code is deployed it into the perf environment. Please go and verify it and see if all works good. Let whatever they wanted to verify from their side. Your goal is to ensure that it is deployed, running, and tell them that it is working. Am I solving the problem called configuration inconsistency here? I'm solving it, right? Why? It's the same image that I'm using across all the environment. Pretty much there will be no differentiations because your application is running from the container, which is common in all the cases because image is same. It is not using any OS level settings or host OS settings, and it's very quick as well, right? Let's say for some reason, right? Let's say for some reason one of the containers got stopped. Unexpectedly, the container is got terminated. Okay, for some reason it is terminated. Tell me how much time that it takes for you to bring up the application again. Seconds. That's it. It is run over. It's now running, right? So that's the power of the container images. So within a second, you can recover your application or you can recreate your application. It will back to running state. You don't need to worry about doing a lot of struggle here because everything is already packaged it into a image format. Just use the image, run a container. That's it. Your application is started. Of course, as of now, I'm showing you dev, QA, perf, all the containers running in the single server. That's okay. We'll be keep on doing some more improvements as well because if my EC2 server is down, all these containers will be down, right? It's not a good practice. We'll definitely do some more enhancements to that process as well to make it more better. Of course, whatever the automation that you wanted to can be done, right? Whenever it is stopped, you put your automation in place to start it back again. All these things possible anyway. Are we good so far? I think this is the story for today, guys. I spent a lot of time because I don't want to just show some commands. I'm showing in, you know, by following some process as well involved here. The other reason why I'm putting more time on this, believe me, once I go to the Kubernetes, it's very hard to understand the Kubernetes concepts. So how much good that you guys are having the container basics, that makes your life easier to understand the Kubernetes. If you're not familiarizing with the container concepts, you will go mad in the Kubernetes. It's very hard to understand the Kubernetes, guys. So, so be familiarized with this container concept, how the container is working. So it will be easy in Kubernetes. Thank you. So we'll talk more in tomorrow. We'll try to do some more enhancements, more best practices.
Well, sir.
Yes, please.
So suppose we will create an image from container by using this docker commit command.
Correct.
Okay. And then if we want to run the application, we will then make a container by using docker run command.
Yes.
And then docker run, it is created, and then we will go into the browser, put IP address, colon, port number, then the application will come.
Yes.
Okay. This is a way to access the application. Okay.
You
Means
have
that
to.
if the container is created and it is running, the application will already run.
Correct.
Okay.
Correct. So from these concepts, right, you need to grab the technical part and the use cases, what that each step is doing. Okay. The process may keep changing. Today I followed some process and that will be keep changing when I go to the next level of classes, guys. Any other questions to me, guys? Hope you are good.
Sir, we may need to reserve the IP address, right? I mean, for example, if so, you're giving the IP address to the end user and telling to access them, but just in case if the IP address changes when we build a new EC2, so we need to reserve this, right?
Interesting part. Interesting part. So give me a second. I really wanted to open one other slide for you. You come to this particular slide, right? Your end user, whoever is accessing your website, is he really using the IP address to access the website? No, right?
No.
The end user will be using the website like www.edwiki.in. That is resoluted, and the traffic will come to load balancer. Load balancer will be routing the traffic to EC2 server, right? This is the flow, correct?
Yes.
So in today lecture, right, rather bringing all those story again, I'm just straight away putting the request to the EC2 IP just to see that my content is accessible. But when it comes to the real time, right? No, you will never be using the IP address the way how I did it today. When it comes to the real time, right? The process again going back to the concept. The user is hitting the website like the actual real domain name. The traffic will come to load balancer. Load balancer will be giving the traffic to the target group. target group will be giving the traffic to one of the EC2 server. Now the game start. That EC2 will now be forwarding the traffic to one of the container running inside a EC2.
Okay.
Right? Previously till
Yep.
EC2 the story got stopped. Now inside the EC2 there is a container, right? The same flow will go towards the container as well. So today we are discussing about the container layer, how the container works, and I'm just directly accessing the application pointing my EC2 IP. No, right? When you go for the real time, yes, all these things will matter.
Can we have a demo of that, sir? Maybe later.
Not later. It takes another 20 days to come to that level.
Oh,
Okay.
thank you, sir.
So that means for next 15 days, I will be talking about only the containers, how the container works, only that layer. Once we're done with that container part, how that works, then I will be going back to AWS one more time. Then I will be connecting our AWS concepts with our container concepts. I'll mix them. I'll put into a final flow.
Sure. Thanks.
And what is the length of this course?
You are referring about the Docker Kubernetes concepts?
Correct. The entire course, Docker Kubernetes.
Docker Kubernetes, I'm expecting at least 3 weeks, 3 to 4 weeks.
3 to 4 weeks. Okay.
Yeah, that's how big topic it is. At least 3 weeks it will take.
Yeah, I have just one small query. So you changed that index.html to a custom web page, right? This is a custom page or something you mentioned instead of the default. So, and after that, when you wanted to see that whether that custom page has got changed or not, so you ran docker exe, then the container ID, and then the cat /user/local/apache2/htdoc/index.html standing inside the host, right? From the host you ran that command, docker host.
Correct.
But could have been, can we also run the bash? Can we go to the bash shell of the container and then see that? Is it possible instead
I
of
think I
running
have
direct?
shown the both, right? So if you wanted to go inside a container, then you need to use -it interactive mode, specify the container, then use
In bash,
bash,
yeah.
then that will go inside a container.
Right.
Then you go to the location where you wanted to, see the content and cat the file.
Index to. Yeah. Okay. So both ways are possible. Standing inside the
Obviously,
host
right?
also, as well as you can go
Obviously.
inside the container.
Obviously, I just wanted to show you both methods, the both differences as well. That's the reason. No, each time when I'm trying to, I'll try to use at least the other alternative methods so that you will be familiar with all. Yes.
I actually don't have a doubt, but I just wanted to confirm if my understanding is right. So yum install docker is the command which we use to install the Docker engine. If we are using Docker, then it's called as Docker engine. Otherwise, it's some container engine, right?
Container engine is the generic terminology. Docker is the specific to the organization. In the sense, let's say out of this technical, if that is your question, then I'll try to I try to give the answer in a non-technical way.
Okay.
Mobile is the generic terminology. Motorola is the manufacturer, one of the mobile company. Apple is one of the mobile company. Let's say I'm carrying the mobile. Is generic terminology. Mobile can be made of any company, right?
Yes.
So container engine is just a general terminology, generic terminology.
Okay.
The container engine is just a software that will handle the containers. That's it. Who is developed this software? Is it a Docker? Is it a IBM? Is it a Red Hat? Got me? There are different companies who are actually developed the container engine flavored software. If you look into the Google and ask for the container engine types, sorry, right? So the containers can be from Docker, can be from Red Hat, can be from, you see Cloud Foundry, can be from, there are a few other as well, right? So there are 15 more as well. There are many. Alexi, right? So all these guys are actually somehow they have their own container engine technology, right?
Yeah.
So let's say either you install Docker engine or you install Alexi engine or you install, let's say, Rancher engine, something like this. So that is the software takes care of, or that is the software which will be acting as like a container engine.
Oh, yeah, I get it. Like it just mentions the software that we are using.
Correct. So container engine is a general terminology. Docker is very specific. The company who is actually providing you the container engine software.
Okay. And one more thing, the Docker pull, like we'll be mentioning the image name. Then it will be downloading it from the Docker hub. That it downloads to the like the host, Docker host. The image will be downloaded to Docker host, right?
Correct.
That means the OS of the OS we are using, server.
The image is downloaded and that is stored into the Docker host level, or yes, this image is downloaded and it is currently available on the Docker host, which is your EC2 level.
Okay. So when we run the command docker run and the name of the container, then the container uses this image.
Correct. This image
So
is used and the container will be created.
So likewise, we can use a number of images on our EC2 level and then use that image, to create the containers.
It's true.
Okay, I just had that doubt. Like we can use the different images for different containers.
Obviously, right? So in this case, if you see that I'm actually pulling the images of different applications. As of now, as we are targeting about Apache HTTPD as one of the example application, I pulled that. But yes, you can pull the any image that you like it from Docker Hub, then use that image and start creating a containers.
Okay, so the image is at both ends, like at the OS and also in the container.
Okay, from the terminology wise, right? From the terminal, your understanding is correct. From terminology wise, the image will be downloaded and kept in the host machine level. The image is extracted into a container and the application is running in the container, because we should
Okay.
not use the term called image is inside a container. No, the image content is extracted and kept into a container. It's like if I give you a zip file, if I ask you, hey, use the zip content, you can't use the zip content as it is, right? The zip content will be extracted and it will create a one other folder for you. In that folder, you see the extracted content and use the data. Your zip file will still remains be the same at a source location sometimes, right?
Yes.
Same thing. The image is still there in the OS level. The image content will be extracted, kept into a container model, and it will be running the application over there. So the terminology, like the sentence formation, is little different.
Okay. So in real time, we'll not be using these many images, right? Like we'll be using one application and in containers, we'll be using the services of the application.
Yes, but what is the case if I wanted to, as of today, if your website is running on Apache HTTPD, then you use one image. But what is the case if my website is using a Tomcat image, Tomcat application, Nginx application, a Ruby application?
Okay, like it may or may not be in real time.
Yes, so the Apache HTTPD will be supportive only if your code is written in HTML language. If your code is written in Java, it won't work. If your code is written in Python, it won't work. So based on which programming language that the code is written, you need to take the corresponding supporting application, and obviously your images will change now. We'll talk
Okay.
those in later.
Okay. One more small thing, like now the image is in the OS level, and then when we create a container, we'll be extracting that image to the container. Then, as the image is already present in the container, can we delete the image which is at the OS level?
If the again, right, from the terminology wise, it's not a OS level, it is a host OS level. Yes,
Okay.
if the container is a running state, you cannot delete an image.
Okay. Okay, the container works only if the image is present at the host level too.
Yes, of course, you
Okay.
can't delete an image when it is in running state. If you try to delete also, it won't allow you.
Like not the image of the container, the image which is at the host level. Like we have two different images now, like as it is using the image of the host level.
No, there's only one image. Okay, so if you do
Okay.
Docker PS, if you do Docker images, this is the image that you are referring, that the image is currently there in the host machine level. This image is extracted and used to run as a container here. Okay,
Okay.
so this container is not duplicating the image. No, it is not copying and keeping it into the container as a separate copy. No, the same image being extracted and using as a reference to run the container over there. So this container is still pointing to the same image. If you see this behavior, this container is using the same image, this container is using the same image. So it just extracted it into a virtualized logical folder to run the application, but the source reference is still be the same. So there is no two locations where the image is there. It's a single image located in your host machine. This is being used as a reference point, as a template point to run the containers wherever you have been asked for as a isolated fashion. So one image, multiple containers.
Okay, it is just using that image as a base,
Correct.
and it's having its needs based, like with the help of the image that is present at the host level.
Exactly.
Okay. Yeah, I get it. Thank you so much.
Thank you.
So one question. You asked one question that can we run multiple applications in one single container? But my assumption is technically yes, but it's not recommendable. Can we answer the same if you are asked the same question in interviews?
Okay. That is true from your perspective. Okay. That means you can run multiple applications in a single container, but that is not recommended. Okay. That's the point number one. Point number two, right? You should not tell to Docker that, hey, I'm running two applications. You got me?
Yeah.
If you are really running the two applications, at least you need to tell to Docker that in these two applications, one application is my main application, the another application is the side application or secondary application or initialization application, something, whatever the name that you call it up. That means what? Whenever there is a requirement to run multiple applications in the single container, we need to tell that one is primary, the other one is secondary. Then only it is possible. You can't run them as both are primary. You'll get to know what does it mean in the upcoming lecture. But yes,
Yeah.
only one can be a primary application, the other can be a secondary application if you wanted to run it in one single container.
Got it.
That
Thank you.
too, if the business demands for any reason, you need to do, or else try to use only one application.
Okay. Thank you.
Docker will not allow you to run both applications as like a primary.
One is primary, one for secondary. That
One
can
is
allow, right?
secondary. That secondary technically treated as a sidecar container. Like from terminology wise, we call it as a sidecar container or init container. That's the term that we use, the secondary application.
Okay. Oh, that is for proxy.
Yeah,
legitimate
kind of.
use of jobs. Okay.
Proxy, giving some supporting work for the main application, processing the logs, right? Downloading some files, like rather putting more burden on the main application, right? Some other jobs will be done by the other application, supporting application.
Got it. Thank you.
We'll see how to run those supportive like multiple applications in one container as a sidecar. We'll get to know all this down the line. Right, and even the question that I see, right, like as of today my code is there in the image. Tomorrow if the developer changes the code, what to do? Yes, again need to create the image, right? We'll do those things as well coming up in the coming lectures.
Also, can you show an example how to push the images in ECR repository as well?
Definitely, right? So once I come to I mean to say once I'm done with at least basic understanding of all these, right, then I'll jump on to the ECR.
Sure. So yeah, perfect. Thank you.
Yeah. So that will be like end state, right? So we are going
You
level
are
by
right.
level,
Yes.
right? So that's the end state. By the time I go there, yes, we'll be pulling it from ECR only.
Yeah. Got it. Thank you.
Thank you.